Why do computers and game consoles need to restart in order to install software updates? A CPU can only work on stuff in its cache and the RAM of the device, be it PC, Mac, console, mobile, etc. However, such memory is volatile, and loses all its data if it is not powered. To solve this problem, secondary storage exists: hard disk drives, DVD drives, USB disks, flash memory, etc. They hold persistent data that is then transferred to the RAM as and when needed, to be worked on by the CPU. Now, when a computer boots up, a lot of its core processes and functions are pre-loaded into RAM and kept there permanently, for regular usage. The first of this stuff that loads is known as the kernel. They are also heavily dependent on each other. E.g., the input manager talks to the process scheduler and the graphics and memory controllers when you press a button. Because these are so interconnected, shutting one down to update it is not usually possible without breaking the rest of the OS functionality. So how do we update them? By replacing the files on disk, not touching anything already in memory, and then rebooting, so that the computer uses the new, updated files from the start. In fact, Linux's OS architecture and process handling tackles this modularity so well that it can largely update without a restart. Windows places locks on files in use. The reasoning is you don't want to open a file, make changes but not save, and then have something else make changes to the file and save them. Because when you do save the file, you'll overwrite the changes made by the other process. So when your computer is on, a lot of system files are locked. If Windows needs to make changes to one in a patch, it'll set a flag and upon reboot, make the change since the file will no longer be in use at that point. The only correct answer is that it is simply easier to treat the code as immutable, and restart the program whenever you want to change the code. It is more than possible to design systems, even operating systems or other low-level programs which don't need to be rebooted in order to update. This concept is called hot swapping, but it is harder to design those systems and sometimes also harder to reason about their correctness. Imagine it this way. Rebooting to update software is like putting a car into a garage and upgrading the engine. Doing a live update is like upgrading your engine while you are going down the highway at 65 miles per hour.